Hey everyone, I think we're live. I hope we're live. Are we live? Are we here? No sound. There's sound for me. Does anyone else have sound? Michael doesn't have sound. Live in the kitchen. What are you cooking? Rob? What are you going to make me? Okay, other people have sound. Good. Good. Maybe just restart your browser. Michael, or refresh the browser. Perfect video and sound. I don't know about perfect. So, hi everyone. Good morning or evening, wherever you are. Or midday. ESD is nothing compared to copper. No one knows what's going to happen. There's obviously a lot of people it's going to absolutely affect. I'm not sure. I mean, my channel specifically isn't one of them. I've marked all of my stuff as not for kids. But, we're not really going to know what's going to happen until after January next year. And it's a shame that YouTube have done it the way they've done it, I think. Tons of sound, says Julian. But without a vocoder. Could you imagine if I did all this with a vocoder? Okay, that was my worst vocoder ever. Cheers. Not enough coffee yet. I can see some new faces. And I can also see lots of old faces. Not old. Sorry. I don't mean age-wise. So, let's do a quick roll call. So hi to everyone. So, of course, Michael and Azzy and James, always the first ones here. So, good morning to you all. Hey, BLR Rocket Technologies. Woohoo! Hi, how you doing? Good to have you here. Hey, Mike, good morning. Hey, Charles. And Rob. Can't believe Rob's here on time for once. Yeah, that's crazy. What's going on? Mr. Andy Calloway. We haven't heard Crowley for a while. Has no one noticed? No one's even brought Crowley up. Hey, Andy, good morning. As in Andy Roberts. Too many Andys. Not too many. Not enough Andys. Hey, Adam. Good morning, Embedded Hobbyist. Scrollies, as I do. You can't see me scrolling, but I'm scrolling. Hey, Martend. Still scrolling. Oh, lots of chatter this morning. Hey, Jim F. from Calgary. Wow. Can't even talk this morning. Good morning, Ian. Hey, Johnny. Hey, Alex Me. Hey, Crazy Boy 2016 Cashier. That is a crazy name. Good morning, Julian. Hello, Andy Day. And James. Hi, James. Yes, you've released another video. I have not watched it yet. It came out overnight. I will watch it maybe with my lunch today, I think. I hope I will. Hey, Dustin. Hey, Kenny. Paul's here. You made it. Yes. Crowley got too famous. He's on a world tour. That's very funny. Hey, Sherlock Ohms. Good morning. Hey, Alan. Crispy bacon. Oh, yum. Can you bring some over? You'll have to bring it through the back door, though, right? Come through the office. Crowley's in the recording studio doing his the greatest hits, the best of. So I have a cookie. I'm going to eat a cookie on stream today. So Flynn and Yaz made these yesterday, and they're doughy, just the way I like them. So if Alan's going to eat bacon, I'm going to eat a cookie. You watch crumbs go everywhere. Yum. Sorry. I'm going to do it though. It was too good not to take one, because if I didn't take one, they'd all be gone. Adam's browser crashed. So, everyone have a good week? I had a average week. That's okay. I spent way too much time staring at code. It is a biscuit. Cookie. Do you not call them cookies in England? Surely you call them cookies as well. I mean, I think it's an American term, but yes, it's a biscuit. Yum, biscuit, yum. So, it was cold this morning, now it's warm. Better, much better. Oh yeah, how was Bright Day? That looked really interesting. Cookies, biscuits, biscuits, cookies. Hey Christos, cookies equals cupcakes? What? Had a good week making music, trying to figure out code. Awesome. Yeah, I did too much coding this week. I gotta say, I'm not enjoying it. Mike! Give the man a round of applause. Mike was the first one to spot it. I fixed both my lights, look. All the lights are fixed. How good is that? How long did that take me? Jim is learning about thrust vector control for model rocketry. Awesome. Do you follow, what's Joe's website? Oh, what's his YouTube channel? Hang on a second. Open a new tab. Was it BPS Rockets? I got to BPS Space. Let me just grab the link. If you don't all follow, you got to check out this channel. Hey Zulu. So I mean, I'm not specifically into like rockets. I mean, I'm quite happy to watch rockets and stuff, but in terms of building rockets, I think that's way out of my pay grade. But yeah, check out BPS Space. Yeah, he's it's funny because people laugh. He's like a little Elon Musk. He actually looks a little bit like Elon as well. But he's yeah, really enjoyable videos. Really great stuff. So I was going to keep chatting until I finish my cookie. Yeah. Joe Barnard. He's also got another channel where he does less rockets and more random stuff. But yeah, really good channel. Really, everything is self-taught. Sorry, I'm talking while I'm eating. Yeah, I saw him do his fizzy milk. I think part of the problem was it was lactate and not regular milk. I posted asking him to do it again with regular milk, but obviously get someone else to drink it because he can't drink it. But yeah, that was pretty crazy. That looked disgusting. I mean, that would have taken... He would have had to pull the whole soda stream apart to be able to clean it. Like, that was just, yeah, terrible. Hey, Stephen. Good to see you, mate. The red things are M&Ms. Yum. They're all gone now. Shame. Hey, Death Shaker. Sorry, I'm eating a cookie or a biscuit on stream this morning. Just to do something different. Hey, John. How many psychiatrists does it take to change a light bulb? 1. But the light bulb has to want to be changed. Yeah. Sorry. Not as funny as it maybe should be for me. Still too tired. Red wine in soda stream. Oh, really? Kaboom? Okay. Cookie's gone. That was good. We did milk and soda stream at a party when I was 16. Exploded. Bit of a clean-up job. Yeah. John Ram, did you see the tweet about the TFTU's Tiny Pico with a ZIF socket? I did. Did I not reply to you? I thought I replied to you. So the problem is, firstly, it's a different screen. It's the same screen, it's a different ribbon. So it's not compatible with my current screens. There's two different types. And the ZIF socket for it is too wide for my shield. It doesn't fit inside the pin spacing. So I already knew about that one. Yeah, the problem is it won't fit. Yeah, like it's a narrower ribbon cable, but the let me see if I can show you. One second, I'll see if I can show you. So I'm going to switch cameras, even though you get to see what's on my desk, but that's okay. Whoop, not that one. So let me just zoom in quickly. So what John's talking about is, so for these screens, there's a version of the screen that you can get. I hope that's in focus. Version of the screen that you can get that has a slightly thinner cable. It's got less pins on it, and it slides into one of those sockets. The problem is the socket is too wide. The outside edges of the socket that solder it down for mechanical stability hits into where the header pins are. So I couldn't use it, unfortunately. It seems that I really made a big mistake when I made my Tiny Pico so small. What can you do? What can you do? So, but thank you. I thought I replied to your tweet. I'm sorry, John, if I didn't. Maybe I started and I forgot. Am I learning your maths for doing RF matching calculations for the Smith chart? Not a chance. No maths at all. If I have to use maths, I'm not going to do it. And as it is, well, you'll get to see. You'll get to see how much fun I'm having. I've only just started, so I'll let you all now. Let you all know now that the amount of time I've spent playing with it is this much. And some of the stuff I plan to do on my stream today is first time. So I'm going to make an absolute arse out of myself. Just letting you all know. And I can say arse because my channel is not for kids. So, Ziff, he's a character in Futurama, is he? What's your thoughts on the new Cybertruck from Tesla? I was quite shocked when I saw the Cybertruck. I got to say, I was quite shocked. But everything about it sounds fantastic. And I like the fact that they're doing cutting edge stuff, literally. Pun intended. But my initial gut feeling was that I felt like they could have made it a little bit more mainstream. Not mainstream, a tiny bit. But I don't know. I mean, plenty of people were shocked and are buying it. It's pretty crazy. Hey, David Watts. Oi, oi. Hi, all. Looks like the joke channel this morning. It's a joke channel. Maybe it is. Haven't had any funny jokes yet, though. Sorry, folks. How many front-end developers does it take to change a light bulb? I don't know, front-end developers could do that. Super busy tonight. Have a lovely stream. Oh, bye, David. Hi, David. Bye, David. That's a shame. Hey, Ian. Good morning. Astro inside the ISS operated a robot riding an obstacle course here in the Netherlands. It was pretty awesome. Microcontrollers. Wow, that's really cool. Fun. PH. Testing in production. Nice. Who's testing in production? These are not production boards. What I'm testing today. Mr. Us. That truck is ugly. Yeah, it's not for everyone. I mean, I wouldn't buy one, but I'm not a pickup truck guy in general. Learn along with Sion. Yeah, I don't know. There's not going to be much learning for you guys here. Sorry. What do you call a sheep covered in chocolate? I don't know. What do you call a sheep covered in chocolate? Hey, Marin. I thought the front-end developers prefer dark mode these days. Ian thought the truck was a joke. Mars bar. Okay, that's semi-funny. That's semi-funny. It does look like a stealth fight. Like, I gotta say, I felt bad for them when they broke the windows. You know, like Elon he didn't look that unhappy, but you could see inside he cringed a bit. So, for those that don't know, I'm not going to, no spoilers. Go watch the unveil. There's a lot of videos online, short versions of the unveiling. If you don't know what we're talking about with the Cybertruck, Tesla's new pickup truck, go have a look. Don't watch the full video announcement, but go like lots of people did summaries, and it was pretty good. Mike's 1 minute behind live. Why 1 minute? I'm on low latency, ultra low. So there's a reason why I'm waiting and stalling this morning. Honestly, there is. It's a legitimate reason, and that is because my VNA needs to warm up for it to be used. They recommend 15 minutes, but 15 minutes isn't really enough. Isn't a pickup truck called a ute down under? Yes and no. We do call them utes, but they're kind of different. We still have, I think there would, yeah, pickup truck's definitely an American term, but there are different classes, I guess. I'm no expert on these trucks, but I think a pickup truck is something that's bigger than a ute. A ute is generally I think a ute in Australia started out more like a car that was an open back, but a smaller, like car size, was a ute. And then we call them pickups, not pickup trucks. Like we've got bigger versions of them that are more in line with what a pickup truck is in America. We just call them pickups, but definitely an American term. We're trying to get funny jokes this morning. Why did the dog cross the road? Because he was stuck to the chicken. Okay, so that's funny but sad. It's just funny because it's a chicken joke, right? Did anyone here has managed to avoid seeing anything about the Tesla truck? Yeah, maybe not. I don't know. And deliver the pre-orders anyway. They haven't been able to scale production. They haven't scaled production on anything properly yet still. I mean, they've massively ramped their Model 3, but they still haven't reached the production that they were hoping for, I don't think. For me, there was much to learn. Don't know anything about MicroPython. Not mind a few coding lessons on the live stream. I don't think people want to watch me do coding lessons on a live stream. No, coding and live streams don't go too well. No, Holden's still here. Holden's here. All the car companies are still here. Maybe not as big as they used to be. I think Mitsubishi's offshore now. I'm not sure. I'm working on remembering how I used to code STM8. I'm on a new PC, so busy setting up STVD from scratch again. Yeah, I hate having to remember how to set up tools that I set up ages ago. Yeah, Simone's trucklet was pretty funny. She actually had it there at the unveiling. That was pretty cool. I didn't watch the full unveiling because I wasn't really overly interested in the Cybertruck, but I was a bit shocked when I saw the pictures. Anyway, so shall we get started? I think we should get started because this isn't going to take very long to watch me crash and burn. No production of any company. There's no production at all in Holden anymore here? Ah, interesting. I didn't know that. Didn't know. There you go. So I'm going to switch cameras. Let's get started. I think we should get started. Now I'm going to zoom back out a bit. I'm not liking the colour of this matte. I've got to tell you, I'm going to change it. Not now. The blue does look nicer in real life, but it looks really washed out on camera. All built overseas. Well, that sucks. So what have I got here? I'm going to show you what I've got. Firstly, this is the VNA for those of you that haven't seen it. And yes, it's upside down because it's being powered from this side. And I need to access the DUT, the device under test connector. So it is upside down. So for all of those that are freaked out by that, let me just move my microphone a bit closer for you all. Maybe I'll even move my camera a bit. I'm going to spend a bit of time over here, just for the moment. So what I've got here is, let me show you what I've got. I've got to see under which one is which. Okay, so this is it's not a working Tiny Pico, this particular one. It was from that batch that the ground plane was damaged. The internal power plane was damaged. One of the manufacturing faults from JLC PCB. So I've got 50 panels, all where the ground plane is shorted inside. Sorry, I keep saying ground plane. Where the power plane, so layer 3 internally is shorted. So they're all useless. But I built a panel of them So I have 15 of these boards that don't work. They're unrecoverable. I kept them because I could eventually harvest parts off them if I needed to. But yeah, I thought I'd use one of these. So I took off a Pico D4. Let's get a bit closer for you. I took off a Pico D4 and I've soldered on the coax. So it's a bit, how close can I get? That's as close as I can get. So just so you can, just to explain what I've got here, hang on. What does it say on that via? What does it say on what via? What did I miss? Bubblegum sticky mess. Hey Dabletronics. If I miss anyone dropping in now, oh hello Station 240. I'll come back and check the chat in a moment. It's kind of out of my face. That is a dut. Done. Buongiorno. Oh, hello Colin. VNA. What does it say? Are you asking me what this says? It's a MiniVNA Tiny. It's actually a +2 version. It's a vector network analyzer. So this is a clone, a Chinese clone of the original, but it's a better clone. It's got more features and it's more stable than the original, which is a mini tiny VNA. So this is called a +2, although they don't say +2 on it. Wow, MiniVNA Tiny is not cheap. Yeah, are you looking at the clone? Yeah, this cost me $600 from AliExpress. $700, that's not expensive for a VNA, mate. Not that goes up to 3 gigahertz. I mean, a Roden Schwartz is $10,000, so, you know, just saying. And the logo is an antenna design. The what? The logo, oh, that there. Yeah, well, no, that's a Smith chart. Okay, let's get back to this. So what it is, there's a bit of coax. Let me just grab an empty one. So here's some coax, right? And what you've got is the outside shield, right, which is conductive. And you've got the inside. So the inside goes to the RF line, the NLA line, LNA line, and the outside goes to ground. So, and these are just like a pressed aluminium outside. So what you do is, I've had to, it was actually quite hard to get them on, get the outside to actually solder up properly. So I have to scrape the outside a bit with a knife, just to get any residue and crap off it. And then you solder the pin to the pin where well, in this case, the Pico D4 would go for the antenna. So that's the antenna pin there that comes around. And you solder the shield to the ground pad in the middle. And it's a bit tricky and it looks a bit yuck just because it's all fluxy, but that's okay. So this is a tiny Pico that's got a full matching network on it, right? So it's fully intact. The board itself doesn't work, but the antenna does. What I've also got, just excuse the blue tack on it. I don't really need it, but it's just I'm a bit worried about ripping these off. I have my Pro S2, my Revision 2 board. That is also connected to the antenna pin. And yeah, we'll talk about all that in a moment. And then, so both of these boards I've run on my VNA already. And I have a problem. And so that's why I'm going to do some experimenting today live. And I'm going to experiment with these ones. Neither of these have I run off the VNA yet. So this is the same tiny Pico, at the same one of the busted boards, but this one has no matching network underneath. I've taken the antenna off, I've taken the matching network off, and I've just stuck a 0 ohm resistor to bridge the Pi network. And I'll explain why I did that in a moment, because otherwise there's no conductivity to the antenna. And then I've got my Revision 2, my new Nano. This is the one that's on my Reflow Master Pro. And so this has also got no matching network. It's just got a 0 ohm resistor to bridge it, as does this one. This has no matching network, just a 0 ohm resistor. Okay, so these two I've not run before. These two I have. But before I do anything, I need to zoom back out again. I need to calibrate. I'm going to recalibrate my VNA because it's been on for a while and it's nice and warm. It gets quite hot actually. That's okay. It's allowed to. But obviously, there's no point running tests on it. Like it needs calibration data to run tests. I'll come back to chat in a second. And so the calibration data has to be pretty much current to your working sessions. So I'm going to calibrate it and show you how to calibrate it. So let's just quickly go back to chat. So I'm just rearranging my desk again. I should not have eaten that cookie this morning. Give me indigestion. What are, just quickly, what are Suxzors? Really? How old are you, Julian? You don't know what Suxzors is? It's 1980s leet speak. Leet as in L-E-E-T. Do you know that? Hackery speak from the 80s? Sorry. It's funny, I was speaking to a friend of mine, Josh, in New Zealand, and he saw the thumbnail I was going to release, and he said, look, you know, he was worried that not everyone would know what Suxzors is. It just sucks. Suxzors is the, it's the same way as saying sucks. Yes, leet, there you go, and hacksaws. See, these guys got it. Suxzors, hacksaws. Sorry, showing my age, what can I tell you? Where do you get those semi-rigid SMA? Did you carve up a patch connector? No, so these particular, I'm just going to go back to here just for a moment. So these particular ones I got from AliExpress. They're my third batch. I've got a whole bunch of different ones, and so I originally got wrong ones. I got these, which are really thick. These are not semi-rigid. These are really much more rigid, and they're really thick. And I thought I was getting the semi-rigid thin ones, but I didn't. It took me a while to find the right ones because they're all, when you're trying to find them online, they've all got like code numbers, and I didn't know what the correct code number was, and you can't trust anything on eBay. So I bought a whole bunch of stuff from eBay because it was local, so I could get it within like 3 or 4 days, thinking I was getting the right stuff, and I didn't. Ended up having to buy a whole bunch of stuff from Ali. So I found a seller who's got all different lengths. So I bought like, I think 2 or 3 in every length. And you can just reuse them, right? You can take them off, and if they get too gnarly at the end, you can just cut them and restrip them. And you know, I've got that whole length that I can keep cutting back if I need to. So if I don't rip them off the boards, hopefully I can just keep that on the board and keep tweaking the different parts. Let me just go back to chat and see what I missed. Sorry, folks. Pink red tack instead of blue tack looks like bubble gum. Hold your coax to one of your Pico boards. You had it on your desk a few minutes ago. Hold it. If you're talking about that, it's not really holding it. It was more for support when I was soldering it, and then I just haven't taken it off. I can get it out. It's not needed. I'm quite surprised how strong the shield bonds to the pad. But the reason I left it there is because I figured that I was going to be soldering on and off a lot of parts off the matching network, and so there's going to be a lot of heat around this end of the board, and I didn't want to, that's why I left the blue tack there. This is actually a combination of blue, green, and pink. It's a bit yuck colour. Okay, so I'm just catching up on chat again for not heard of a signal hound, Colin, but yeah, like, you know, a VNA is not cheap. I mean, you can get ones that are, you know, the issue if you want to get to Wi-Fi, like if you want to get to 2.4 gigahertz. If you don't, there's stacks of VNAs out there, you know, that can do up to like 1.1 that are really cheap. You know, if you're just doing, you know, 900 megahertz, 800 megahertz stuff. But if you want something that'll go up to 3 gigahertz, that's a whole different story. And I mean, the fact that this is only $600, it's probably ended up costing me about $800 now if I look at all the bits I had to get with it, you know, and all the cables and stuff. Have you tried soldering a 50 ohm SMD resistor to the end of the cable as a reference lead? So I don't have a 50 ohm 0402 resistor. I don't actually have a 50 ohm any size resistor, unfortunately. The closest I've got is 47 ohms. No, but I've got a, well, I'll show you in a moment. We'll keep going. Just let me get into this, but let me just quickly go through. In terms of cost, I was speaking relative to the intended use. Big, expensive, only 1 or 2 designs to test. It's still not, well, okay, so for me it is because I've got an RF guy in China, but to 2 boards being tuned in China is the same price as me buying the VNA. So, but if I get the guy in China to do it, then I get perfect matching, but I get no knowledge out of it, right? And this way, look, I'm not expecting to be able to match my own networks. My expectation is I'm going to have to send this to China anyway. But I'm learning a whole lot of stuff about it, right? And, you know, this is my journey and quest for knowledge. So, and not that I want to become an RF expert, but I don't want to be an RF, I don't want to be blind to it. Like, I want to learn more than what I've already got. Julian's typing on a tablet. Yeah, I don't like typing on my tablet or my phone. Indigestion, easygestion. What? Okay, I'm going to go back. I'm not going to throw up on camera, I promise you. Did Leet Speak ever get to the UK? I don't know if it did or not. I don't even think it actually got to Australia. I don't know. I learnt it all from the movies. And maybe some misspent youth, but we won't go into that. Okay, so don't talk about my bouncer. I don't know what they're about. Won't the length of the coax affect the measurement? Well, yeah, if it's super long, but not really. Not what I'm looking for. Sorry. Like, I'm interested in reflection. And so, yeah, it won't greatly affect it. The manufacturers know if you hit the 3 GHz mark, you must be working in the telco doing LTE jobs, and then you pay the price for it. Yes, it's true. It is true. You finally get your... Yes, Marius? Oh, man. Yeah, a few people have noticed now. I haven't moved to LED. They're still halogens, but I decided to fix it. Could you calibrate the RF signal if needed yourself? What do you mean by calibrate? You mean tune the network? Yeah, that's what this is for, so I can tune the network. Okay, so let's get going. This is probably warm enough now. Yeah. So I'm going to... Don't worry about what you see on the screen right now. This is the software. This is just a scan with nothing connected, so don't worry about that. So what I'm going to do, I'll do a calibration pass to show you what's involved. So this is not a learning lesson. Start with 50 ohm tracks, and then should be less to adjust for, unless the antennas are not 50 ohms. So all the antennas are 50 ohms. So the embedded hobbyist, the problem with that is, just to be clear, you can't just start that way. Like, because I need to do it on a board, right? I can't like make a board that doesn't have the proper layout on it and then tune that and then change the board to get an antenna on, right? Does that make sense? So if you're talking about sticking a 50 ohm resistor on the board on the Pi network and blocking the rest of it off and cutting off the antenna and just tuning that, well, sure, but I don't have a 50 ohm 0402 resistor here anywhere. I could probably try to shoehorn an 0603 47 ohm, but there's no point. Like, you know, the fact is, I've got an antenna, I've got a fairly close trace, which we'll go through in a moment, fairly close to 50 ohms, and so I should be able to work from that. As I said, my expectation is not that I'm going to be able to match these perfectly myself, but if I can get them fairly close, it makes it much easier for the guy in China to finish it off. Any length will affect the readings. So length is a bit over 10 centimeters, this length. Right, but the length of it will affect the phase. Right, it's not going to affect the matching. What I'm interested in is the matching. Obviously, the shorter the end, the shorter the connector, the better. But as you will see, in this particular case, my coax length is not my problem, as you'll see in a moment. There's lots of things that affect it. Okay, let's take a step back. Let's not all just... This video is not about all the things that affect RF. Okay, let's just... Yep. Let's get going. So, to calibrate this, what you can do, there is a calibrate button, which you click, and it pops up another window. And what you do is you run... Does it get bigger? It does, but the font doesn't get bigger. So, oh well. Sorry about the fonts, I can't do anything about the text being bigger, right? So what you do is you run 3 tests. You do an open, a short, and then a load. And to do those, the actual device, well, my one, I bought it with it, comes with 3 different connectors, an open, a short, and a load. The load is 50 ohms, and this is what you use to calibrate the device. So we're going to do that now. So I'm going to take the DUT out. So the first one we do is an open, and so that says short on the back, which you can't really see right now. I know that's the load, so this is the open, that says open on the back. So we put the open on the device under test. Don't do it too tight, you don't want to rip the thread. And we now do a read open. And this will go in, I think it samples 10,000 steps, I think. You might be able to see it going here, it says 24%, 25, and it's going through and it's doing a read. Show first, then go back to chat. Yeah, that's what I'm doing now. Let's talk parts inventory. No, let's not talk parts inventory. I wonder if those RF cables are in inventory systems. Microphone position not optimum. How's that? Is that better? Now it's right in front of my face. There are wrenches for those connectors that torque them just right. I know there are. I don't have any. I'm using my fingers. I'm just being very careful. Okay, so it's done that first one, as you can see. You've got a bit of a graph here. Okay. So now I take that off. And now I put the short on. Gently. And I run the short. This reminds me of my TV antenna cable amplifier, which needs to have a termination screwed on unused ports. Yeah, you need the terminators on them to prevent bouncing. If you want to be pedantic, you should calibrate with the coax open. But seriously, it's super Wi-Fi, not a military radar, so it's not actually the major if you're just looking at the general S11. Well, so the calibration that I'm doing right now is the way they say I need to calibrate the device for use. So I'm just following their instructions. His job is running token ring networks. Cows and lambs, hey? Tabletronics? Cows and lambs? Okay, so that's done. Now we take it off. And we put the load on. It's a 50 ohm load. So they say to do this before every use. But it's a real pain. But we're going to do it now. And T connectors. Hey J-Man, you can't stream 4K. Actually, I could stream slightly high res, but then I get no low latency. If I want to have low latency, I can only stream at 1080p. It's a YouTube limitation. Normally you calibrate out the cable length by calibration open, short and ref at the end of the connecting lead. Allows the VNA to subtract the effect. Right, except in my case, I don't have that, right? So what I've got, it comes with these, which is great, but they're not, so I could do it with those, but they're not the same lengths, right? So that's not really going to help me. It might make it closer, but I don't have any cables that are SNA to SNA of the same length. I could probably order some. But as you'll see in a moment, I do have an issue, and you'll see in a moment what it is. And it's in this particular case, it's not about getting the perfect matching network. So yeah, we'll see in a moment. Yeah, this was I think $650 Australian for the VNA. Okay, so they're all done. So now what I do is I do a save, and I'm going to save this over the top of this calibration, and then I click update. Oops, overwrite, yes. And I click update, and my lights are falling off my wall. That's going to be interesting. My RGB strip. So now this has got my calibration data loaded. So I take off the load. Actually, I'll leave the load on, just to show you what happens if I do a scan with the load. So I'm doing a single scan. And this is what we get. Now that just scanned between 1 megahertz and 3 gigahertz. Crowley's ghost. Who's ghost? So if I just turn the blue off. So it's a little noisier than what I'd like. And so clearly it's not the best VNA in the world. A wang. But as you can see, there's, if I turn auto scale off, so we've pretty much got within the megahertz range that I'm looking, or the gigahertz range that I'm looking, right? Like if you can see as I move my cursor along, I'm sorry about the font size, hopefully you can read it, but if you look at this field over here, right, as I move it along, if I get to the 2.45 gigahertz range, you can see that we're only about, what are we? Just looking backwards, about 8 decibels. So that's not too bad. I know you'd want it to be fairly straight, but that's a pretty close range for the areas that I'm looking at. What are we talking about Crowley's ghost for? I don't know. So what I'm going to do is take off the load, and I'm going to start by putting on the Tiny Pico that has a matching network. So this is the one that was matched by my guy in China, and there's not really an expectation that it's going to give me perfect results, because he's using a $10,000 VNA and I'm using this. But if I do a scan, what we should see is a nice dip, reflection dip, that goes down around the 2.45 gigahertz range and back up again. So I do a scan. Crowley's ghost is pulling your lights off the wall. No, it's really just bad sticky tape. Whoops, auto scale back on. So, can everyone see that? I wish I could... Oh, really? I gotta rescan it. It gets rid of the drawing when I scale it. That's annoying. Okay, so this is what we get. Now that's pretty cool. Now if you look down here, I'm just going to put a marker. I'm going to stick the marker over here so you can see it clearly. Hello. There it is here. I don't know if everyone can see the 1. And what I can do is I can just scroll my mouse wheel to move it. So I'm going to move it down to the very bottom of the peak. And as you can see, that's an SWR of 1.24 to 1. That's pretty damn good. I mean, 1 to 1 is the ideal, but 1 to 1 is pretty much impossible to get. Right? So that is my Tiny Pico's tune network. Right? So 2.452 gigahertz. Right? And Wi-Fi is 2.45. That's pretty impressive. Right? The fact that it's tuned so well, and my belief is that a better VNA would probably do a better job of that. And if I bring up a Smith chart for it, you can see here, actually what I'll do, let me just close the Smith chart for a second. I'm going to just add 2 more markers. Hey Saket. going to add 2 more markers. I'm going to just add, I've got to remember which keys are which. I want to grab, I'm going to stick just one there and one here. And I'm just going to move them until the decibel points, so this is decibel here, is at the 3 decibel mark, the -3. So 3 is at -3 and 2 is at pretty close to -3. So this is the range we want. Can you show a poorly tuned one? Well, yeah, we'll get there in a moment. Just wait, hold your horses. Okay, so they're the markers, and the -3 decimal point is on each side is pretty much the range we want to look at. And if I open up the Smith chart, you can see there's markers on the Smith chart. Hopefully you can see the green on the black. This chart here, I don't know. I don't know if it's Fourier. It's called a Smith chart. So the center point here of 1, where my cursor is the ideal point. That's what we want to reach, right? And this is where we are here. So if this was exactly tuned at 1:1, that box would be sitting right in the middle. This is the ideal for matching. And the way this chart works, and I don't remember the exact, so please, you can correct me if I'm wrong. It doesn't matter. I'm not going to be specific. But each quadrant, if we put a line down the middle, and there's already a line through here, each quadrant of this circle indicates inductance and capacitance. And either, this is not going to be right, but for example, if it was over this quadrant here, then this could be too much inductance and too little capacitance, right? So for instance, to move something from here to here, you might increase your capacitance, and move it from here to here, you might increase your inductance. Does that make sense? Top is inductive, bottom is capacitance. Thanks, Colin. Yeah, as I said, I'm not an RF expert at all. I'm glad Colin's here. So that's how you tune your network, right? You've got there are multiple types of networks, but if you have like a pi, which is it looks like a square, like pi, or you have a T, which means you've got a component, then a component, then a component. Then by playing around with different values and positions of caps and inductors, you can reposition these points, right? And I went through that on a stream a little while ago, and we can have a look at that a little bit later. So to me, that's a fairly well-tuned Tiny Pico. Now you remember, I can't go and just check any board with this system, because I need to get a board, I need to pull off whatever chip is on it, if there's one on there, and I need to solder on coax. So I can't just go and take a TTGo board and compare it to this, right? Not going to happen. Just letting everyone know. So what I'm going to do now is take my Pro S2 and scan that. And I want you to all have a look at what we get. So when I did that scan the other day, I was very excited. Very, very excited. And I couldn't wait to... So I did my Tiny Pico first. That was the first board I soldered. Because I wanted a reference point. I wanted to know that my setup was working. So I wanted to take a known, good, matched board and make sure that my VNA was picking up okay. So I've now plugged in my Pro S2, which is just here. So this is using a different antenna, and this has got no matching network on it. It's just got a 0 ohm resistor bridging. And let me show you just quickly why I've done that, just so everyone's clear. Eagle. So if I go, this is my Pro S2. Let me just rip up. So this is the matching network just here, right? If I don't have something here, if I don't have a 0 ohm resistor bridging this here, then the trace is disconnected. It won't get to the antenna, right? That's why I've got the 0 ohm resistor just here, just so everyone's clear on that, right? So let's do a scan. I'm just going to remove these markers Okay, single scan. Dun 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 dun. Holy moly, what a mess. That is a bad, bad scan. That is a very bad scan. So that is not a scan of an unmatched network. That is a scan of a problem. Hey Graham. Well, it's not overly complicated just by visually looking at it. But it's a bit of a head mess. So I spent some time, a couple of hours yesterday, trying to work out what the problem is with my Pro S2, why I'm getting readings like this. Because this looks like noise. This looks like garbage. Okay, what I should be getting is not a perfect plot like I got before with the Tiny Pico, right? But I should be, as in, what I should be getting is something that looks similar, a bit noisy, but similar in terms of its shape, but at a completely wrong position outside of the 2.45 gigahertz. Wow, I got real bad indigestion this morning, folks. Sorry. Serves me right for eating a cookie live in front of you all. So I started doing some looking into my design. Now remember, this is the first time I'm using the Fractus antenna instead of the ProAnt antenna. And the Fractus antenna has some slightly different implementation requirements. Yeah, it was the cookie, Mike, I'm pretty sure. Oh, Crowley, you're right, Andy. Crowley is back in town. He must have heard. Yep. Can everyone hear? So what I started looking at was, okay, let me just bring back, I started looking at obvious things. And to me, obvious things are, for instance, well, what about my trace? Because obviously this is a completely different layout. Peter's match is far off resistive point. Look at your Smith chart image of the scan. You want to see this? Yeah. Okay, so I'll show you the Smith chart. I should have done that. Look at my Smith chart. This is totally FUBAR data. Looks fine for me for an unmatched antenna. RL only goes down to negative 2.5 dB, so it's unmatched all over the place. Right, it's unmatched all over the place, but what I did yesterday, just for I guess shits and giggles, is let me close that. Okay, so let me put a marker in on where the 2.54 gigahertz is, right? The 2.45. 2.45-ish. This is roughly where I want to be. This point here, 1, those can see, is that's where I want to be matching 2.54, right? So what I did was I worked that out. I plotted my graph, and as you can see where we are over here. And I took those values into SimSmith, and I can do this exercise again with you in a few minutes, or a bit later. And what I did was I actually made a network to get it back to the 1. I'm very far off the 50 ohm center point. That's the problem. I'm way too far off. Anyway, so I made a matching network. Unfortunately, the network that I had to use was a T network, and currently on my board I've got a Pi. So that's the first problem. I'll have to do a board redesign. But the values of the components I needed to use to tune it were so tiny, like I don't have them, even with my test, all my RF samples that I got, I don't have values small enough. The fact that I had to use such small values, right? And the other problem is it thinks that my network is 90 ohms, not 50. right? It's just, there's something wrong. It shouldn't be this bad, okay? And I'm a zero, just so everyone's clear, I'm a zero expert, yeah? I'm a zero expert on RF. I've never claimed to be anything else. But from my understanding, an unmatched network, I should have something that's a bit better than this to work from. Anyway, so what I wanted to do was, the reason I connected some other boards is I wanted to try an unmatched tiny pico and see what I get. Sub picofarad. Yes, it was sub picofarad. Tiny. And I also wanted to try my nano. So my nano uses diffractus. It's a different layout of the matching network and the antenna. The length is different. The position of everything's different. We're all minus 3 dB experts, Julian. So I want to try the nano, a scan. I'm going to do that now. And I want to try the tiny pico. I want to see what we get. Both of those are unmatched, but they're both using 2 different antennas. So let's do that first, before I do anything else. I just want to do that just to see, because I've not done it. Right? One was soldered up this morning, and one was soldered up yesterday afternoon, and neither of them have been run yet. Have you impedance rotated? You have impedance rotated by your cable length. What do you mean you have impedance rotated by? I understand my cable length is going to affect things, but if you look at the tiny pico that I did, which is using an even longer cable, that's visible. Bit hard to see on that screen. Anyway, I'm going to take this off. The first one I'm going to run is a tiny pico with no matching network, which is this one here. It's because you're in Australia and everything's upside down. Well, it's quite possible. I mean, at this point in time, it could be anything, right? I'm not even on the chart anywhere. Okay, so I'm just going to delete that. So I'm going to do a scan now. This is my first time ever. I'm going to do a scan of an unmatched tiny pico. Right, so this is an unmatched. Did I do the right one? Let me just check. It'd be crazy if I put the, what do I call it? No? Okay. This is an unmatched tiny pico. There was only a 0 ohm resistor bridging the network. And if I click, hello, and I put that down, so as you can, so this is what I expected to see, something like this. I would love for this issue to be that the thin traces going into the square pads creates a microstrip inductor. Okay, so we'll get to that in a second. Colin, when you commit the national from the VNA reading, you need to compensate for your cable. Okay, but here's the thing. I'm not even at that point. What I'm trying to show here is this has nothing to do with cable length, right? I just scanned an unmatched tiny pico using the same pi layout with a 0 ohm resistor bridging it, and look at the graph I get. Now, it's in the wrong spot. It's at 2.54 gigahertz. So it's far from ideal, right? Like, it needs to be shifted. But look at the graph. Try the Smith chart program using your measured impedance. Okay. Yeah. I'm not sure I'm making this clear. Sorry. I'm not trying to match anything right now. Right? I'm not trying to match. Forget about the matching network. Forget about the Smith chart. Okay? Forget about all of that. Look at the graph I'm getting from an unmatched Tiny Pico compared to a matched Tiny Pico, right? And then look at the graph I got from an unmatched Pro S2. Do you understand? I expect to see a graph similar to this for an unmatched, hey Michael, for an unmatched Pro S2, just in the wrong spot. I don't expect to see a bunch of noise like I saw. This is unmatched, what you're seeing right now. So now I'm going to take this off and try the Nano, which is using the Fractus. Okay, this is now using the Fractus antenna on a Nano. I'm going to do the same scan again. And I'm expecting to see garbage again. Maybe the antenna isn't soldered properly. Well, I checked it. I've been over the board. Right, here we go. So using the Fractus antenna, I'm getting this again. So they're two different antennas. Stupid question, but is the VNA on the right pin on the S2? Is it on the right pin? You mean the antenna pin? Of course it is, yes. It's on the right pin. This is on a Nano, which is using the Pico D4. So this is the same as my Tiny Pico, but using the Fractus antenna, right? With a 0 ohm bridging it. It's a different layout, but look what I'm getting. So there is something inherently wrong with the way I am using the Fractus antenna. So I'll give you a link to the Fractus antenna. 1 second. Bear with me a moment. Let me just switch screens just in case I open something that I shouldn't, because I need to find it. Oh, I'm glad I did that. Okay, Fractus. What did Paul write? No, it's not a bad question, Paul. But I've been through all of that, right? Okay, so this is the antenna I'm using. No, it's not for a twin antenna. The Pi board D, Damien George's new MicroPython board, uses this antenna. He doesn't even have a matching network for it, right? So that's a link to the antenna. Actually, let me just go back to here. So this is the antenna I'm using. And if we look at the, I think it's the user manual. If the link works, it may not work. Do we get a 404? Sometimes we get a 404. Hey, Robert Froxzwerg. What is the scale on the left? It's just a flat line zoomed in way too far because it always zooms min max. I can turn off auto scale. There you go. Yeah, it's terrible. Like, this is not what I should be seeing. Like, it's only going to -2 decibel. Maybe test a Fractus antenna direct at the end. Hey Kenny, didn't even know you were here. Hi, bye. So let me just go back to here for a moment. It's my browser. There we go. So this is the antenna. If you look through the user manual, it's here are the specs: 2.4 to 2.5 gigahertz. It's 50 ohm. They talk about some implementation cases. This is the what we should be seeing User manual says it needs a Pi config. Right, and I've got a Pi config. That's what my matching network is. Right, if we look here, there's my Pi. Now I am doing this, which is a little bit funky, but my Nano is using a Pi, but doesn't do that. In fact, my Nano's trace is tiny. So the obvious things I started looking at was, okay, let's look at my trace width, right? My trace width is 0.3048. Actually, that's not true. My current ProS2, it's 0.254, so it's a little bit too thin. One of the factors right onto the coax without a board. Well, I don't have coax to. Oh, I could. Does anyone want me to do? I can do that. Just hold on. Get another cable. I'll try that in a moment, but I just want to go through some of the things I looked at, right? So if I go to the KiCad calculator, I don't know if you guys have seen, for those of you that use KiCad. So this is a PCB calculator that comes with KiCad, and they've got a transmission line calculator. So if I put in all of my settings, right? So if I look at the this 0.18 is my let me just go to here and show you DRC. If I look at my layers, okay, so it's a 4-layer board. So what this is, wrong window, hang on. I've now got too many windows open, which is really annoying. Oh, it's not going to be doing them at the same time. So here I've got 0.18, which is my height of my prepreg, and 0.035, which is the height of my copper. Okay, and I don't really know what my ER rating is for the antenna because I couldn't find it anywhere. If I look at the width of my trace, so if I go, the width of the trace is actually, in this case, on the ProS2 right now, 254, and my separation is 12 mil, so it's 0.3. At 50 ohms, and I do an analyze, it's telling me that my trace is 58 ohms. Now, it's out. It should be 50, right? There's a lot of chat going past right now. I'll get back to it in a second. It should be 50, right? So I admit that that's slightly out, but that shouldn't be giving me the problem I've got right now. And if I do put it back to, I mean, I have changed it to be right, but my Nano is using 0.3048. My Nano's trace is 52.5 ohms. So that can't explain why my Nano is all over the place. Okay, so the minimum you expect to see is outside the frequency range. Right, my expectation is that for an unmatched network, I should be seeing a normal looking graph, but not at the frequency range that I need. And there might be some noise on it. But like I said, if I go for those that missed it, I'm just going to quickly go back to here. I'm just going to stick my unmatched Tiny Pico back on. Unfortunately, my unmatched one looks the same as my matched one, so I need to find the right one. So this is unmatched. It's got a Pi, but it's only got a bridge across it. Right, if I just scan that again. So for everything that I've read and everything that I understand, this is what I should be seeing. Something like this. Right, now in this particular case, where it's getting down to in terms of its range is not low enough. It's not low enough and it's not at the right position. But, well, if I go and if I stick a marker on it, right, and if I put the marker at 2.45, where I want it to be, this is where it is on the Smith chart. And I need to shift it to here. That is a reasonable expectation of an unmatched network that needs to be shifted to match it. Hey, Id. So it does seem to suggest that there is not a good connection on the actual antenna, just untuned wire noise. There's definitely something wrong, but the fact that it's on my Pro S2 and my Nano, and both of them have, and they're both using two different chips, right, which means the pins are different, their positions are different, the path to the matching network and to the antenna are different, but they're both using the same antenna and they're both giving me unmatchable results, pushes me towards an issue with the antenna. But I don't know what it is. I don't have another board here that has that antenna on it that has a working configuration. Right? I don't have a Pi board D. I'm sure you expect a minimum somewhere. The question is it just outside the range you can scan? Well, maybe it's outside the range. I don't know. I mean, this is... it's quite possible. Hi, Yaz. Good morning. Okay, so let me try soldering on an antenna. I will do that. Contact Fractus from Orange Show. Well, yeah, I need to contact Richardson's, who are the people that distribute the antenna. It's just totally not what I was expecting, right? Could the antenna actually be backwards from instructions? Well, I damn well hope that the instructions were correct. My icon. What? Oh, I love your icon. Right. I think the little picture, your avatar picture on chat, I think if two traces are parallel with other traces on a lower layer, is there some capacitance? Yes, there is, but in this particular case, you got to remember, just very quickly, that we have, let me just fill it. So there's a ground plane, but obviously the antenna is sitting outside the ground plane. And then we have, so that top layer, layer 0, or we'll call it layer 1. Layer 2 is a ground plane. So this is an inner ground plane. And as you can see, this is to specs. There's supposed to be a ground plane underneath it. Right? And then we have our layer 3 is our power plane, which is this orange, which as you can see goes nowhere near it. Right? And then layer 4, which is our bottom. There's a logo under here, but that's not connected to anything. So that's ENIG, but it's not connected, right? It's just floating. There's no way that's affecting it because my Nano doesn't have anything like that on it, right? 2.4 to 3 is 600 megahertz out. I doubt it's that bad. Well, it could be out that much. I don't know. It just, I find it unlikely. Like if my trace is pretty close to 50 ohms and the antenna's 50 ohms matched, you know, like it's not like I have, I mean, there's about, hang on, there's about 15 millimeters between the pin on the chip and the antenna on the Pro S2, but there's only about 5 millimeters on the Nano. So it does not make any sense to be that far out. So if I've missed any questions, you need to at me just so I can see them. Normally antenna is base driven, meaning signal goes into one end and the other end flats in open form, but possibly the solid Fractus type goes signal. No, it doesn't go to ground. You don't ground it. And both pads on the antenna are connected together. So if I stick a multimeter on and do continuity between the two ends of the antenna, they're connected. It specifically states in the manual, do not ground the antenna at the other end. No, it's not the wrong way. So if I just go back to here, I've double, triple checked all of that. So if you look here, this is not, P2 is not connected to anything. It's just floating as per the instructions. P1 is the antenna in. And if I Pro S2, let me switch cameras. And as you can see here with the configuration, the white marker on the antenna is the antenna point according to the documentation. and the other end is the other end, the non-grounded end. There's no ground, right? But the floating end. So it's on the correct way based on the documentation. I've double and triple checked that. Why does the antenna track flip back on itself? Why does this one here flip back? Well, ideally it would go this way, but I would have had to rotate the antenna, and I would have had to bring this around, which I couldn't because there's stuff in the way, and it would have increased the length of the antenna trace, which then affects the phase. And I didn't want to. The shorter you've got the NLA trace, the better. Now, on the Tiny Pico, the length of the LNA trace is twice as long as this. So, length of the trace in phase is not a problem. Bye, Id. Thanks for joining. Have you tried swapping antenna pins? Swapping the antenna around? I haven't. I mean, I could, but I don't think that's the problem. There shouldn't be any ground plane under the antenna. It seems like you have one. Where does it say there's no ground plane under the antenna? It doesn't say that in the manual anywhere. And it's a common practice to stick a ground plane, not top ground. Like if it's a 4-layer board, it's common practice to stick a ground plane under the antenna. And there's nothing in the documentation that states not to do that. Unless I missed it, and I've read it quite a few. Figure 4 in the manual. Okay, hang on. Where's the manual? I had it open here a minute ago. I think if you're talking about figure 4, I think you're talking about 2, 3. Where's figure 4? No. Figure 4? Or are you talking about this? Which one are you talking about? Only exposed to unicorns. Figure 4 on the manual. You mean point 4? So where are you looking? Page 9. Page 6, 7, 8. Page 9. Clearance PCB without ground plane. They're talking about a top layer ground plane. They're not talking about an underneath ground plane. So I don't think... I'm not sure this is clear of all ground planes. I'm not sure. It doesn't... Yeah, I don't know. I don't read it as that. I mean, I've read quite a few antenna manuals. That page Smith chart shows a circular impedance pattern. It does, but not as bad as mine. Look, it could be. Maybe the issue is I've got the ground plane underneath. It's possible. It is possible. I have to say that the documentation for this manual is very poor. Sorry, documentation for this antenna is very poor compared to the Pro Ant. So on the Pro Ant and even on the Rain Sun that I soldiered off, the original one, they were very specific about its use cases. Very, very specific, like in terms of you must have ground here, you must not have ground here. If it's a 2-layer board, you must do this. If it's a 4-layer board or a 6-layer board, you must do this. In this particular one, they're very vague. Interesting that the feed traces is from the end on that diagram, not from the side. So which diagram are we looking at again? Sorry. Do it in the ground plane area, not in the clearance area. So, hang on. You guys are referencing the manual. Where in the manual, David? Hey, David, does it say do it in the ground plane area, not in the clearance area. I don't know what that means. I can't cut the ground plane away. It's inside. It's in a layer inside the board. It's on layer 2. So I can't cut the ground plane away. Same diagram. So page 9, was it? So what am I looking at? So I'm trying to read chat at the same time. Page 9, last paragraph. Right, the matching network has to be in the ground plane area, not in the clearance area. And that's where it is. Look, my matching network is in the ground plane area. See here? This red, that's ground plane. Okay, it's not here. It's not outside the ground plane. So my whole matching network is inside ground. This is ground, this is ground. This trace here, well, that's a little bit unorthodox. But any issues caused by this should be able to be corrected by tuning the network. Hey, Brian. I'll see you, Jim. Catch you later. I'm referring to the PCB feed trace entering the antenna from the end, not the side. Once again, well, in an ideal world, it comes from the end, but I can't do that. So any change of configuration you do should be able to be mitigated by tuning the matching network, right? So I don't believe this is necessarily a problem on the way the antenna's coming in. It shouldn't. It definitely wouldn't explain the results I'm getting. The ground plane, maybe it could. Figure 3 from the shows a PCB silhouette and there is no copper under the antenna. Right, but they don't. Once again, so figure 3.3. Right, but this picture right here, that's a 2-layer board. Okay? They're showing you a test configuration board, and it's a 2-layer board. So, once again, they're not clear. Look, it could absolutely be the ground plane. Don't get me wrong, I'm not saying it's not. That's not something I can test without making another board. Cut the tab off the PCB and float the antenna off the end. Ugh. Yeah, that's going to be that's going to be kind of tricky. But yeah, okay. I bet it's still with calibration. I've seen this many times. Hey Pontus. It's still with calibration. But yeah, I'm not sure it's with calibration because my tiny picos are scanning perfectly. Keep an area free from electronic components, traces, and ground plane in all PCB layers, and then assign the PCB directly underneath the mounted area. Where did you see that, Bruce? Keep an area free. Where did you read that? Sorry, I want to see where Bruce saw that, read that. What was it? Keep an area free. I wonder if I can search for that. Fine. Keep an area. No, it's not letting me search the document. 0 ohm resistor and have the antenna floating outside the PCB. From their site, another PCB can't post a link. From their site. I have their site. Well, this is their site. So which other... You're talking about the data sheet? This data sheet link doesn't actually work. From their site, chip antenna integration. Chip antenna integration. Where did you find that? Under tutorials. Sorry, Johnny. Okay, I'll have to look. Okay, so it could be the ground plane. because that's the only thing that the Nano and the Pro S2 have in common is that ground plane. But you got to, I don't know. I don't know. Okay, so the first thing I'm going to do, I'm going to grab an antenna and I'm going to solder an antenna on the end of one of these cables. I need to grab an antenna first. One sec. Okay, where is my iron? Okay, I'm gonna have to plug my iron in, find the cable, 24 volts, gonna make sure I put the right one in, and turn it on. Okay, I just want to quickly clean up some of these things. Need to put my calibration bits away. Okay. Google chip antenna guidelines practice. Okay, I'll have a look at that, Bruce. Thank you. Look, if that's what it is, that's what it is. I was going to do another spin on the board anyway, so that'll give me an opportunity to try that. But if it's not what it is, then I'm still going to be back to square one. But honestly, I have to say, watch their place antenna video around the 35-second mark. Okay, oh, hang on, we've got a link. Open a new window. Clearance, so keep an area free from electronic components, traces, and ground plane and all PCB layers and underside of the PCB directly underneath the mounted antenna. Wow, okay, well, I completely missed that. Antenna on the corner of the PCB as far as possible away from other components such as the batteries, connectors, especially those components and covers with metallic characteristics. Yep. Place pads for the matching network compatible with close as possible to the antenna feed point. Do it in the ground plane area, not in the clearance area. Yep, did that. Transmission line and RF chip. Design your transmission line so its characteristic impedance is equal to 50 ohms. Well, I'm as close as I can be right now. It'll be 52.2 on my next design. As well as the output impedance of the RF chip. Locate your RF chip as close as possible to the matching network in order to reduce the loss. Yep. Area underneath the matching network. If possible, avoid any ground plane under the pads of the matching network in any layer placed. See, this is really interesting because all of this stuff here, this here, and this here, this is the first time I've seen this for any matching network and for any RF. This is not what the Pro Anti is, not what the Rain Sun is. It's not what the Molex is because I was looking at the Molex instead of the Fractus. So that's quite interesting. Like especially this, no ground plane underneath the matching network. That's completely opposite. RF is a bugger to fix. It's not a bugger. It's yeah. Unfortunately, it's not like I can click my fingers and get a brand new PCB, right? That's not going to happen. And that kind of sucks. Now, I've only got a really long cable left to do this with, and I don't particularly want to cut it. So it's going to be a long cable, but it should not make a difference. I'm going to try to do this just under the camera, if I can. So that is the correct end. If I turn it over, you see there's the white. So I need some solder. Is iron hot enough? The problem is I don't have a ground plane. This isn't really going to work because I don't have a ground plane. How am I going to test this without a ground plane? Maybe I've got a better idea. Hold on a moment. Rather than soldering an antenna onto just one of these, Because remember, I can't put the ground plane on the other end because it's not supposed to be grounded. No, the other end is not grounded. Hey Ben, the other end is supposed to not be grounded. It has to be floating. What I might do though is, on my Nano, I might take the antenna off and flip it around. I know it's not great, but hang it off the end of the board. Maybe, I know, but the other end needs to be soldered. Not really. If I hang it off the end of the board, it should get most of the antenna out of the ground plane. Yeah, I don't understand how they can't use a ground plane either, but anyway. Need to order a few more. Yeah, I'm going to order some of them, some more. I don't know how I'm going to easily get this antenna off though. I'm going to have to hot air it off. Damn, okay. I'm just going to turn my iron off again because I'm not going to be using that. My concern is if I hot air this off, it's going to potentially, let's go over here. I'm going to potentially rip the coax off, which is going to suck. Add an additional one to get the antenna out of the PCB area. Additional what one? Antenna radiation works in 3D, that's why you must not have a ground plane under the chip antenna. Hey X Micron. Well, it depends on the antenna, because the Rainsun requires a ground plane under it, and the Molex requires a ground plane. So yeah, like I made some assumptions. Mainly because I didn't see that documentation, so that's on me. That's, you know, that sucks. But let's have a look. Let me see if I can get this antenna off without ripping the coax off. I'm just gonna. I'm just using that for light, so I can see what I'm doing. Where are my tweezers? Here we go. Kept on tape over the coax. That's a good idea. That's a good idea. We've got stacks of Kapton, and I always forget. The antenna manufacturer specifies ground or lack of. Pliers and a torch. A torch. Just think of the ground plane being a whole lot of small caps connected. Right, but yeah, my point is that the ProAmp needs it. The Rainsun, the ProAmp needs ground plane on top and on layer 2 or layer 2. The oh, I just stabbed myself. Anyway, let's just take this off. I'm just gonna try to rotate it 90 degrees, see what happens. Okay. This may end up bad. I know you can't see what I'm doing, sorry. Okay, it's off. I'm just rotating. It's going to be far from an ideal test, I know. Just want it to cool down a bit. Might actually leave the Kapton on. It might affect things a little bit. So I'll just show you what I've done. This may be a total waste of effort, I don't know. But that's what I've done. I've just rotated around so it's hanging mostly off to see if I get any improvements. That's all. This is so interesting. I'm not getting any coding done. Sorry. And I'm glad you find it interesting. I'm not sure I'm finding it interesting right now. No, I am. You know what? If it just turns out to be the ground plane, I'd be super wrapped. I really will be. If it's... I'm quite happy to make it my mistake. Quite happy. Okay. So, not that you can really see what's going on, but I'm gonna switch it back. Just look at the Fractus website. Did not see your antenna, but their Duo extends seams. Same technology of fractal antenna. Broadband 1 GHz, 60 Hz with no specific tuning. What the? Yeah, it's really bizarre. Their antennas are really... Yeah. Okay, so here we go. I'm going to do a scan. So I'm expecting to see something kind of like this, even if it's a bit noisier. Sorry, I haven't moved my camera back. Hi, everyone. So, single scan. Here we go. Right, look at that. So that's even worse. That's even worse. So clearly hanging it off the edge is no good. So the only thing I'm going to be able to do is 4, 5. Look at the Smith chart. Yeah, that's terrible. Depend tiny bit on edge coupling. So I'm just reading the chat. I seem to have missed a lot. It's changed a lot, but I'm not sure. I mean, the position has changed completely, but it's still within that 0 to -2 decibel range. So clearly placing it where I did like that isn't going to work either. Also, we'd like to see just a scan with the coax soldered to the... Right, Wolfgang, I can't, because how do I... There's no ground if I do that. Does that make sense? Or does it not matter? I mean, in the case of the Fractus... Okay, I'll do it. I'll solder it on, just on one end. Just floating, but I'm not sure what that's going to do. That's all. If I can anyway, I'm going to do it. Let me just switch. I'll try it out. Dremel off the third layer from the board. Yeah. Just solder the one end to the wire like you were going to do no ground plane. Yeah, I'm going to do that now. I'll see what happens. Okay, why is my iron's off? Okay, it's warming up. Make sure I've got it the right way around. I do. Just going to put a bit of solder onto the antenna and then put the cable on it if I can. Don't really see what I'm doing. I'll get off. Wow, that's too much solder. But, okay. Okay, it's not ideal, but it's on, I think. It's definitely on. Let's turn the iron off before I burn myself, because I will. Everyone knows that, right? Okay. So I'm just unscrewing And I'm zoomed in, you can't really see what I'm doing, sorry. I'll rectify that in a moment. Okay, so I've got it connected. And we go back to here and do a scan, single scan. We're 0 to 8, minus 8. So, different results again. We're sitting over here. It's in a more tunable position. I mean, it's got a couple of SWR of 5 to 1 right now. So, yeah. That's just hanging it off the cable. Oops, moved it. Damn. Okay, well, looks like I'm getting some new boards made. I will, while we're at basic things, what about trying to heat up that joint again? Heat up the joint. So which joint? Hey Cran. So I'm not sure what you mean, Wolfgang. Heat up what joint? Coldest solder joint ever. What's wrong with the solder joint? You reckon there's a problem with the solder joint? I can definitely shoot Richardson's an email. I don't think there's anything wrong with this solder joint, but let me... Just bear with me a second. I'll improve it under my microscope, okay? Just to keep everyone happy, swap the pin just for test. No, it's not the pin. It's... Nah. There's no point. I don't think there's any point swapping the pin around. Now that solder joint's fine. I mean, it's a pretty good blob of solder. But... probably should have removed a whole bunch of the solder, which I'm doing right now. It's going to clean it up a little bit. But there's definitely nothing wrong with it. I should have done it under the microscope to start with. Sorry, I'm far away from the microphone. Apologise. Okay. Okay. A much cleaner result, but I'm still going to... I'm not sure it's going to make much of a difference. But I'll do it. I'll scan it again. Let's scan it again. Try entering from the end instead of the side of the antenna. Yeah, that's what I just did when I fixed it. So this is, it's going straight now. As you may be, let me just... It's really tiny. It's going straight now. I should have done it under the microscope to start with, just so I could see what I was doing. So this is what we're seeing now. It's actually reduced the range in decibel, which I'm not sure is a good thing. And if I plot it, it's actually further away now than what it was. So it was actually closer when the antenna was the other way around. Could try tombstone vertical mount now on the PCB. No, I can't tombstone it because of where the pad is. It's not around, the pad doesn't go around the side of the antenna. So I'm not sure how I'd stand it up. I don't think standing it up would work. I don't think I'd get it on there. Are you certain it's not supposed to be grounded on the other end? It specifically states in the documentation not to do that. Bum, bum, bum. Sorry, where is it? Let me find it. Sorry, 1 second. It's very, very clear. Here. Mounting pad 2. Solder the antenna mounting pad to the soldering pad on the PCB. This pad must not be grounded. Must not be grounded. So, you think it's a bad batch of antennas? I don't know, about 100 of them. They cost me a fortune. I definitely hope they're not a bad batch. So as you can see here, pad 1, the feed pad, has got the white box around it, and the other pad doesn't, and they're very clear. No ground on the other one. Hey IVH, does it make a difference to lift the antenna off the grounded EST pad? It's not grounded. That pad's not grounded. That pad's floating. If you look over here, the pad it's on here, the second pad, it's floating. There's no ground. Must it be floating or connected to something else? No, connected to nothing. It wouldn't make any sense to connect it to anything. It's there for stability. It's there for so the two ends of the antenna are connected. So let me show you. Which is why it can't be grounded or connected to anything else. So if I go to here, let me do it on. I'll do it on this one just to show you. So I'm gonna stick it down, hopefully. So I get my multimeter. Everyone hear that? These two ends of the antenna are connected. The two pads. Oh, I can't get to both sides of it. Anyway, yeah, they're connected. So that's why it can't be grounded or connected to anything else. Pretty sure you'll get good results if you redo the PCB without the ground plane. The cable only result shows a good trend. Match frequency is probably above your VNA range. Yeah, look, I'm gonna have to do it anyway. I've got a new design sitting here anyway. So yeah, this design moves one of my pins. Hang on. Oh, sorry, you can't see what I'm looking at. Apologize, let me change. In RF, that doesn't mean much. You can have a specific pattern in between rather than straight. No, I understand that there is a pattern inside that chip. It's a full 3D antenna. My point is that My point is it can't be connected to something else. Like you said, if it's not connected to ground, would you connect it to something else? Like what would I connect it to? That pad is there for stability, I'm pretty sure, for mechanical strength. So I need to go and make this. So they also said that the matching network should have no ground underneath it. Well, that's really interesting because that's going to be a problem. Well, not really. So I'm going to have to... Oops, not there. Okay, so I'm just going to frig with my ground plane. So they want no ground plane under the matching network either. And I'm not sure how I'm going to do that, to be honest. Oh, God, I hate how Eagle does this. Okay, so can I talk to Fractus? Well, they're in a... Possibly. I don't know. I mean, I'd have to work out who I need to speak to. I'll probably have to speak to Richardson first, and they're going to have to put me on to where I need to go. Just cut out a polygon. Well, like, yeah, I could, but I wanted to. I just want to see what's involved. So no ground plane underneath it. So let's see what that looks like. So that's the ground plane now. So there's no, it's not under the matching antenna, and it's clear of the antenna. If you're ordering boards from DLC, you could try one of their test footprint that they have in their manual. This way you can validate test footprint. What do you mean by their test footprint? A test footprint in their manual. You're talking about the calibration board? There's no point, using a calibration board, well, unless I want to test that the antennas work. Could you also rotate the SMDs 90 degrees so that the matching network is also closer to the antenna? No, there's no room to do that. Where can I possibly fit the matching network in 90 degrees? I'd have to go to 0201 components. It needs clearance. It can't be near the JST connector, right? I mean, there's a JST, not massive. There's a JST connector sitting here. So if you look at that, let me just go to here. Just give you a bit of, so you can see. There's no place for the antenna to go. I can't get any closer, sorry. There's no place for the matching network to sit. Even though if I went 0201, which I really don't want to do, because I can't mass produce them. It's going to cost me more to make the boards. I just can't squeeze it in. We need to call in signal path. There must be a bat symbol. Yeah, that'd be cool. In the antenna manual, there's a test jig that they use to get their antenna specs. Yeah, right. But the only reason I'd want to build one of those, Pierre, is to actually test that my antennas work. But otherwise, like, what's the point? Because I need to tune it to my exact board, so the antenna trace has some sharp bends. No, it shouldn't really matter. I don't believe, as I said before, I don't believe this here is the issue, because my Nano doesn't have this. Right, my Nano is a different configuration. It's even shorter, and it doesn't have this kink, and it's got the same problems on the Nano. Oh, Colin's going. Thanks for joining, Colin. Thanks for your help, your RF help. It was very much appreciated. What if you rotate the Pi 180 degrees? I don't think... Well, it's going to get the end. If I did it 180, well, it can't be 180. I mean, it's got to be flipped, because well, either way, it's going to be the same result. Okay, right. But if it was the other way around, then the antenna's line is going to be coming too close to the JST. I don't think I'm going to have enough clearance. Maybe I will. So you're talking about, let me just save this. So you're talking about doing something like, I should have turned those other layers off. Just 1 second. Let me just get rid of these. I mean, I could look at doing something like that. I'm not sure. I mean, that also breaks conventions. Ground side still connected to ground with the ground plane removed. Is the ground side still connected to ground? Yes, there's a top ground layer. So the matching network here is sitting inside the ground plane. It just says there should be no ground plane under it, which I find that very hard to believe, I gotta say. But so that'll give me something like that, which is, you know, I guess it's possible. Yeah, the top ground is still ground. The antenna is small, monopole. This would need some form of ground plane. This must be the rest of the ground plane. So, what was that? The antenna is small, monopole antenna. This would need some form of ground plane. This must be the rest of the ground plane of the board, which may be why they give dimensions on the track and spacing, etc. But it specifies in their documentations that this should not be a ground plane. Yeah, with software it's easier, right? It just works or it doesn't work. Even with some hardware, but then with some hardware it's just not. I mean, I'm not sure that this is going to give me anything any better, to be honest with you. If you can fit a ground via between the trace and the battery connector, it should improve isolation. Between where and where, sorry? This battery, these big shield marks, they're not grounded. So where, via where? I'm not sure what you mean, Ben. I mean, this is still grounded. Let me just get rid of some of these layers. Go away. I mean, I've still got isolation here. So that kind of works. And that trace is pretty ugly. But I can, you know, I can fix that. I mean, I guess there's enough isolation there still. Taking advantage of the space filling properties, this small mono ideal for use within indoor highly scattered environments. Were you reading all this, Embedded Hobbyist? I assume you're just reading through the manual. Oh, right, okay, Ben, I understand, yeah. Well, I've got there's no stitching really, but I'm not also, yeah. I haven't grounded these pads. Yeah, interestingly, I've not seen a design that grounds these microblade pads anywhere. So, I'm not overly worried now. I mean, there's a via. I could easily, I don't think there's anything in between. I mean, I probably should have stitched along here a bit better, maybe, but it doesn't matter because there's no ground plane under there. Like, yeah, see, there's not a lot of ground. If I go back to, if I turn my yellow, so there's not a lot stitching this red ground plane now. There's a little bit. There's a via there. Maybe I just need to stick some more in. Whoops. That's not what I wanted. It's probably a bit better. Come back. You're reading the data sheet. It's a good reading. Make the antenna trace between the network and the antenna horizontal and shorter. Sorry, what? Make the antenna trace between the network and the antenna horizontal and shorter. Well, I can't make it horizontal. Not without moving the antenna up, which I can't, or the matching network down, which I can't really. So, like, how does... There is no shorter than this. The only way to get this shorter is to, straight line between 2 points, make it an odd angle, which I can do, but hey Jess, can you take it from the middle component? No, it's got to come out. No, it's got to come from the end. This is not a problem, guys. This bit here is not a problem. There's no way this is causing the issues we're seeing. DFJB, I don't know what DFJB is. A stub. You can't just connect it to the top of the cap. Connect it to here. I mean, I guess, but once again, like like that, I really don't think that's going to make much of a difference. Sure, okay. Assuming that I keep it, it helps with the OCD. Okay. Yeah, assuming that it stays in a pi and I don't have to redo it as a T. Okay. So that's what I'm going to do. I'm going to have to respin the board. I'm going to have to do the same thing with my Nano, which kind of sucks because I'm going to have to pull the one off my Reflow Master Pro. I'm probably not going to redo the Nano because they're just too expensive for now. I'll redo the Pro S2 and I'll see if that helps it. There's a lot of dark poking. Hey Sienna, why wouldn't you be able to keep a pi? Just my original test was showing that a T was working better for matching, but that was before we worked out that potentially the ground plane was causing the issue. If the removal of the ground plane gives me a better graph like I was expecting, then a pi won't be a problem. Yeah, I was just referring to using a pi instead of using a T for the network. That's all. Wow. So there you go. VNA RF matching. Kick my ass is what it's done. Kick my butt. Pie, makes me hungry. Yeah, I could do like a berry pie. Yum. That'd be yum. Turn my iron off? I did turn my iron off. So wasn't that fun, folks? So hopefully, yeah, we might have an answer to what this problem is. Hopefully it's just a ground plane. I'm finding it very hard to believe that it was, but there you go. I've learned something I never wanted that I never want to do this. Yeah, look, I'm doing this all for learning, right? Like I don't plan to become an expert RF guy. I don't even plan to become a 10% of an expert of an RF guy. But for prototyping and being able to potentially tweak. I mean, if I could get this close and I don't have to get it professionally matched, that'd be great. Like I know what I need to get it as close. If I can get as close to the Tiny Pico, I'd be happy. Anne of all trades just showed us how to make an apple pie. Yeah, not quite. But it's pretty interesting reading the results from the VNA. and learning how to use it. I don't know what 99% of the data is in there, but I kind of enjoy playing around with Smith charts. There are, like, in terms of, you know, tweaking matching network component values to replot the chart, and I'll do that. So my plan is going to be get these boards remade. The good thing is I don't have to build a whole board when I get it. I just need to stick an antenna. Like, I just need to basically do what's on here now. And the reason I stuck the JST on is just because there's a lot of metal and bulk here, right? So having this connector is definitely going to change the attenuation of the antenna. So not having it on there would give me a slightly different result than having it on. So that's why I put it on. So all I need to do when I get my new board is solder this off, stick an antenna on it with a 0 ohm resistor, stick a JST connector and a cap, again because it's just metal near the antenna trace line, and try it. And I'll do that live, folks. Why not leave positions on the board for both? I don't have room. Hey Rich, there's no room to stick both on there. I mean, look how small the board is. I mean, these are 1 centimeter gaps, 1 centimeter squares, right? Like, I don't have room to stick a T and a pi, and all that will do is make the trace length considerably longer, like at least twice as long, which is going to give me phase issues. You are correct. It is a folder monopole. I saw a pattern and assumed it was fractal. I think the other ones are the square ones. I know 100% more about antenna matching now than I did before. Only related problem in the digital world is like bus termination. I don't know. I'm starting to know more about RF than I want to know. So there you go. I'm missing this chat between the embedded hobbyist and Teletronics. I'll go back and read about that later. So there you go, folks. That's my stream today, I think. Yeah, there's really, until I get my new boards, there's not much more I can do about it. But I'm definitely excited to get them redone, and I'll do another stream about trying to match it. A stream or a video, but probably a stream. If you'd all like to see that, I think that'd be cool. It's all too small sound. You want to work on projects that cover your desk. No, I think covering my desk is too big. I'd like to work on projects that are just bigger, that don't need such small stuff. Going to ask, other than the project with your reflow oven, do you have a solder fume extraction? I do. Oh, you were talking about that. I've got two. So I've got. Oh, let me see if this will reach. Oh, it will, because it's not plugged in. So I've got my fake Hacko, which works really well. But it's a fake, and you can tell it's a fake because the label comes off. I got that from eBay. Can't remember how much it was. Very good. Little noisy, but that's okay. And I also have, if I can get to it, because there's a light in the way. Oh. I have before I got that, I made myself this one. So it's just using a fan from a PC and vents, and yeah. So, but it's pretty gnarly. So that's what I used to use. Not that I use extraction much. What will you do if the respin of the board makes no difference? I will. Well, at that point, I'll definitely have to contact Fractus, but I don't think contacting Fractus right now is going to help me when clearly I haven't followed their guidelines that I didn't see. So that's my own fault. I didn't hunt. I just made some assumptions. I read their manual. I saw that they didn't mention a bunch of stuff, so I assumed it was the same as normal. I didn't go looking for more documentation. I probably should have. I feel like all their ground plane stuff should be in the manual for their antenna. Not having that stuff in there, to me, is a major oversight by them. But the fact that you guys found some of this information shows that the information's there. So there's no point contacting Fractus right now when what I've implemented is against their guidelines. I'm going to use their guidelines, and then if it doesn't work still, I'm going to contact them. Yep. I may have went overboard. What did you buy, Brian? Please don't die. I'm assuming that's to Brian, not to me. Install an echo and blow the fumes out. To know enough so that you can talk with the experts who do know. Sure. I don't think I'll ever learn enough to do that. My ventilator is built from a 100mm grow op ventilation fan and inline carbon filter. Well, sure, I'm using an inline carbon filter and stuff for my reflow oven, but for just soldering at the desk, probably doesn't need it. Try playing with copper tape and a bit of copper-free PCB, making ground planes and tracks as per their docs. Yeah, I'm not sure it's worth doing that. Like, there are people using this antenna and it works, so I got to assume that it's my implementation. Oh, so Brian, what did you get? Brian's gonna. Firstly, why did you get something? That's the question. Oh, wait, it's a YouTube link. Oh no, it's not a YouTube link. Holy moly! Okay, 1 second, folks. This is what Brian just got himself. Solder smoke absorber fume extractor extraction arms. Yeah, I've seen stuff like this before, but wow, why'd you get something so big? Or does it just look bigger than what it is? It looks massive. Why did you do that? Both is only 2 extra components. To allow for 2 is only 2 extra. Right, Rich, but it's also... Well, firstly, I don't have room for 2 extra components right now. I'd need to redesign the board to fit it in. And I wouldn't want to leave them all on the final design, which means I'm going to take a board, I'm going to match it, and then I'm going to change the board again, which does when I remove what I don't want. So, yeah, I'm not sure that's the way I want to go. So it's actually not even 2 extra components. I could probably get away with doing 1 extra component tagging on the end, but I'd have to change where the LNA line comes from into the antenna, which means I'd have to bridge it with another resistor, which is going to change the impedance. So yeah, I don't know what the advantage is in doing that. They specify a Pi network for theirs. I've got a Pi network, so I'm going to stick with the Pi. That is, I have it here, and it's loud as hell. Also doesn't come with a remote on off. Hey, Accurash. It's hard to explain. It has an LED light. This one is massive. It's on casters. Yeah. Well, there could be little baby casters, right? I guess even if it's a little bit better than the desk one, maybe it's worth it for health. It doesn't look like a Dalek, but it looks. That would scare me coming in the middle of the night, seeing that, these tentacles. It looks powerful. Smoke it there. Looks like equipment Ghostbusters carry around on. Yeah. That's insane. Did you really buy it, Brian? Why? That's crazy. I got an auction a few weeks ago. Post-bad auction. With the cost. Also, the auction was a company that made me redundant. Now they've gone bust. They went bust because they made you redundant? Shame. At least you got redundancy before they went bust, though. It's kind of like the car seat for your kids. Probably buy the best one you can afford. Then I bent underneath and ran the 4-inch flexible cable up around the back. That's a good idea, Brian. That's interesting. Oh, sorry, Bruce. Attaching the fan under the desk. So you got a hole in the desk? Is that what you're talking about? 220 pounds! Holy moly. I would have bought a Hacko like mine. And I think it was Ian. I don't know if Ian's still here. He's probably gone to sleep. Ian has got like a Hacko like mine. I think he's got an original maybe. And he moved it away from his desk and put a tube on it at the front so he can move it around and it makes less noise. It was actually a clever idea. I thought about doing that too, but I haven't got around to it. He's got a video about it on his channel. So you should check that out. Ian Scott Johnson's channel. Is it too late, Brian? Have you bought it? Is it coming? That's euros. Is that worse? I don't know. Euros, pounds, whatever. Oh, Ian is there. See? His ears were ringing. I came across it. Love the way it clipped in. Oh, you're talking about came across this video? Okay, yeah. It's ordered. Well, there you go. Look, there's nothing wrong with safety, Brian. But that is massive. You got a tiny workspace. Like, where are you going to fit that? That looks huge. Holy moly. And why do you need two? Like, okay, anyway. I can't wait for you to make a video about it. Can't wait. I want to see an unboxing video. I want to see a video with one end you soldering, right? And one end fume extraction and the other end wrapped around your neck. That's what I want to see. Under my desk, I hope. Nah, not a chance. Not with the way they stick up at the top and out. Maybe behind your desk. You can remove one. Yeah, but why would you remove one? Couldn't you buy a unit that only had one then? It fits perfect under the table. Okay, so it can't be too big then. I want to see it making breakfast. I want to see it playing sound. Like, they look like speakers. I think it's pretty cool. The one I got at auction was £500 new. Wow. Get some ear protection. Wow. That is crazy. Good on you, Brian. For someone that doesn't like spending money, well done. That is pretty full on. I'm shocked. I saw you chatting about it online, but I didn't know you were getting, like, not that, but just in general, you were asking questions about it, but I didn't know what you were going to do. I didn't expect that, though. Usually EU prices are higher than US prices, and everything has the same EU price. I still don't get why there's a euro, but anyway, I'm not in Europe. I'm as far away from Europe as you can get, so it doesn't worry me. But yeah, like, same thing, Michael. Like, Brian's, I wouldn't call him a miser, but he definitely doesn't like spending his hard-earned money, so I'm quite shocked that he went all in like this. Brian's going to be the healthiest maker. He just won't die as quick as the rest of us. Is that true? That's the thing. I think it's too late for me. I think all the damage has been done for me already. For the amount of fumes I've been breathing in over the last 12 months. I want to see what like, I can't tell the scale of it from this picture, so I'm still looking at the picture. I know you can't see it, but like, I'd love to know what the scale is next to a person, an averaged height person. So definitely can't wait for an unboxing. He's spending his money before the end of financial year. I get it. I think modern medicine will prolong our life and suffering, so we'll all live 250 years, but Brian might suffer less in the process. I'm pretty sure that will happen just after I die. So, yeah, like, I think that all the medical breakthroughs that could help me in my future are going to happen just as I die. That's just my luck. Sadly, the rescued koala died. Okay, I'm not sure what koala we're talking about. If that makes me a bad person, I'm sorry. Okay, folks, I think it's time to wrap up. Unless anyone's got any more questions. I'm happy to answer more questions if you want, but just warning you all that OBS has been running longer than it should, and it could die at any moment. The matching backpack. I'd like to see Brian walking around with that attached to his back. You could, oh my gosh, next Maker Faire, you could do that. Are you still using a DIY fume extractor for the reflow oven? I am. It's still sitting in that tub, and whenever that oven gets used, the fan gets turned on. Absolutely. It's do not use the oven without it. It's a very fair to say I don't like sending money or spending money. You don't like spending money, but you can definitely send me money if you want. No worries, James. Thanks for being on the stream, as in the chat. Thank you all for being here. It's been awesome. I got schooled today. on reading the documentation. There you go. What do they say? The assumptions are the arse. No, was it? Something bad about assumptions. Whatever it is, I can't remember what the saying is, and I proved it. The dictionary definition of it. Wow, that was almost a faux pas. Instead of ending the stream, just leave it running while you go get breakfast and coffee and see how long it lasts. We'll have to go up the road and get coffee because we're out of milk. Oh, I thought the koala going extinct due to the fires burning all their food. I hope they're not getting extinct. That'll be a shame. That's the one. Assumptions make an ass out of you and me. Well, they made an ass out of me today, didn't they? Yep. That's the one I was thinking of, Andy Mouse, and I'm glad I didn't remember it because I didn't want to say that out loud. Yes. So there you go. But hopefully it might be an easy fix. Fingers crossed. So, that is it. I'm going to wind this up. I'm going to say thank you to all for joining. It's been great having you all here. And, yeah. I have no idea what I'm going to do next week, but I probably won't get my boards back in time for next week, I don't think. Even if I get them into production today, I'm pretty sure they won't get back here in time. Oh well. Definitely something accomplished, I think. I'm hoping something accomplished. I look forward to doing the other end of the matching where we can play with Smith charts and values and you can see all of that. I think that'll be great. But otherwise, catch you all later. Thank you. Once again, I forget how to stop the stream, so that's going to be interesting. I'll work it out, I guess, at some point. Yeah, there's no go live. That's right, I have to refresh the browser. That's what I have to do. And then click the go live button. But I'm already live. And now I can click end stream. And there you go. Bye, folks. Have a good night's sleep if it's nighttime. If it's daytime, have a great productive day. And I will catch you all later. Bye.